Hey, this is Mr. Leach with Simpson Math, and today we're going to be talking about random variables, specifically discrete random variables. I want you to pause the video, read the question on the screen, try the 4 parts to the best of your ability, and in a few seconds, I'll come back and explain the solutions. So let's find the probability that x equals 5. For a probability model to be valid, the probabilities themselves have to be valid. That means it has to be between 0 and 1, which they are here. The probabilities also have to be non-overlapping. So that means if someone rates their pain as 2, they're not also going to say that it's 3, so that works here. And additionally, all the probabilities themselves have to add up to 1. So if I'm going to find the probability that x equals 5, I'll just do 1 minus the sum of the probabilities that we know. That's because we just have one probability that we don't know. So that's 1 minus 0.9, which ends up being 0.1. So I will replace my probability that x equals 5 with 0.1. Next, is a pain score a discrete or continuous random variable? Explain. Well, it's discrete. We know it's discrete because it takes a fixed set of values with gaps in between. Next, find the probability that x is less than or equal to 2. Well, that's just these two probabilities, so we just need to add those up. X is less than or equal to 2, that means 1 and 2. So I would do 0.1 plus 0.2, which is 0.3. So we got to answer, is this the same as the probability of x is less than 2? Well, less than 2 is just 1. So that's the probability that x is less than 2 is just 0.1. So no, the probability that x is less than or equal to 2 does not equal the probability that x is less than 2. Next, compute the expected pain score and the standard deviation of the pain scores. In order to do this, I need a formula or two. And on our AP statistics formula sheet, if you're taking AP stats, we have these two formulas. We have the expected value of x and the variance of x. Additionally, we need to know about the standard deviation of x. We need to know that it's the square root of the variance of x. So let's start with the expected value of x. So expected value of x is the same thing as mu sub x. So we have 1 times its probability. So what does that mean? Well, if you look at our formula sheet, we have it's the sum, that big capital E looking thing is a capital sigma. So it means the sum of x times p. Well, that's xi pi. Those i's are just indices. That means the first one's with the first thing, the second one with the second one, third with the third, so forth. So we have the first x times its probability, so 1 times 0.1, plus the second x times its probability, so 2 times 0.2. And we continue that pattern on and on and on. I don't want to write all those things out, so we'll just say plus dot 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 plus. We get 5 times 0.01. When you do the math, you end up with that being 3.1. Next, let's find the variance of x, or sigma squared sub x. It's always a good idea to find the variance first when doing random variables. Let's look at the formula. So we have that capital sigma, which means sum up, and then you have xi minus mu sub x. That is just a deviation. So we have the first x minus the mean, then we square it. So this deviation squared should feel familiar from when you learned how to find the standard deviation at the beginning of the course. So we have our deviation squared, then times its probability. Again, we have those i's, it just means the first term with its first probability. We would do that with the second one, which would be 2 minus 3.1 squared times 0.2. We continue that on and on and on. Let's get to the last one, which is going to be 5 minus 3.1 squared times its probability of 0.1. Throw that through the calculator and you end up with 1.29. Well, we're not quite done yet because that's not the standard deviation. So to find the standard deviation of x, let's just simply square root the variance of x. So it's the square root of 1.29, which is approximately 1.136. So our final answer in part D is that the expected value is 3.1 and the standard deviation is 1.136. Just to note that you can find those numbers in the calculator, specifically if you're using a TI. So you can put in as a list your values. So put all your values in as a single list, then put your probabilities in as a separate list. Make sure that they are in the same order. And then find the one variable statistics. Your X list is going to be your value list, and your frequency list is going to be your probability. I hope that this helps you understand discrete random variables just a little bit better.